Greetings to our fellow classmates and our lecturer, Madam Rose. Today, my group is going to present on the topic data description.
Hello, I am Yashwant Sukumar.
Hello, my name is Eric.
And I am Navid.
Okay, what is data description?
Introduction to data. Statistics has a wide range of uses in the field of science, business, industry, economy, medicine, education, agriculture, and so on. Statistics. Science that deals with collecting, classifying, presenting, describing, analyzing, interpreting data to enable us to draw conclusions and making reasonable decisions. What is data description? Data description refers to how the results from research studies are organized, summarized, and characterized statistically. There's two types of data, qualitative and quantitative. Quantitative contains discrete and continuous. Mean. There are several kinds of mean in various branches of mathematics, especially statistics. For a dataset, the arithmetic mean, also called the mathematical expectation or average, is the central value of a discrete set of numbers, specifically the number of the values divided by the number of values. Mode. The mode of a given set of data is the observation with the maximum frequency. The first step towards finding the mode of the group data is to locate the class interval with the maximum frequency. Median. Median is denoting or relating to a value or quantity lying at the midpoint of frequency distribution of observed values or quantities, such that there is an equal probability of falling above or below it. Variance. In probability theory and statistics, variance is the expectation of the squared deviation of a random variable from its mean. Informally, it measures how far a set of random numbers are spread out from their average value. Standard deviation. The standard deviation, in brackets SD, also represented by the lowercase Greek letter sigma or the Latin letter s, is a measure that is used to quantify the amount of variation or dispersion of a set of data values. Interquartile range. The interquartile range, in brackets IQR, is a measure of variability based on dividing a set of data into quartiles. The values that divide each part are called the first, second, and third quartiles, and they are denoted by Q1, Q2, and Q3 respectively.
Do we have any homework for this week?
As usual, I think wait. I think we also have a maths assignment that we have to do. It's on chapter 6. It's called data description. So basically, you have to collect any kind of data. Do you have any suggestions?
How about we collect the kind of students in our class?
Oh, I suggest that you create a WhatsApp string message. We ask for their names and their height. Greetings to everyone and our lecturer, Madam Rose. Today, I'm going to explain about the data of high distribution of 0 to 4. Okay, let's start by explaining the first row. Okay, the first row consists of class boundary, class interval, frequency, unit frequency, midpoint x, x squared, fx, and fx squared. Okay, first and foremost, I would like to explain the class boundary. The class boundary consists of low boundary and upper boundary. Okay, so moving on, we have class interval. The class interval has its respective frequency. Okay. For the first class interval, which is the height between 150 cm to 154 cm, there's 3 people. The next class interval, which is 155 cm and 159 cm, there's 3 people. So basically, for all the class intervals, there's people in that frequency. Okay, moving on, let's move on to midpoint. How midpoint is obtained is basically you have to add up the class interval and divide it by 2. Okay. Moving on, we have midpoint square. Basically, the value obtained from midpoint, you square it. Okay. Then we have fx. Fx is frequency times midpoint. So basically, the value you have in frequency, you times it by the midpoint. So we you add up all the frequency, you obtain the total fx. Finally, the frequency times midpoint square. So you have the frequency and you have the midpoint square. You basically times and you obtain the fx square. The total fx square is 629687.
Okay, now let us move on to the calculation part. Okay, mean. This is the formula of mean. Summation of fx over summation of frequency. So summation of fx is 380, which is calculated earlier, and the total number of frequency is 23. So when we divide, we get 165.27 cm. So this is mean. Now let's move to the mode. Okay, mode. The formula of mode is lower boundary of the class containing mode. Okay, the lower boundary of the class containing mode is number 6. Because mode is the part where we get the highest frequency. So it's meant that the lower boundary of the class interval is 164.5. So 164.5 plus bracket D1, which is difference between the frequency of the mode and the previous class frequency, which is 6 minus 4, you get 2, over D1 plus D2. D1, which is 2, plus the difference between the frequency of the mode class and the class after the mode class, which is also 6 minus 4 is 2. Bracket, close bracket, C, which is class width. The class width is obtained by subtracting the class intervals, which is 5. Okay, the answer is 167 cm. Okay, now let's move to the next part, which is median. The median is, the formula of median is lower boundary of median. Okay, now how to calculate the median? Median is total number of the frequency divided by 2, we get 11.5, which is lies inside the accumulated frequency, which is 16. Because 10 is 11.5 is after 10, so it lies in 16. So the lower boundary of the class interval is 164.5. Okay, then and is total number of delta divided by 2, we get 23 over 2 minus cumulative frequency before the class median, which is 10. Okay, the FM over FM, which is frequency of the class median, which is 6, and times with the class width, which is 5. We will get under 65.75.
Now let us move on to the calculation of variance. So the formula to calculate variance is summation fx squared minus summation fx bracket square over summation f, which is the total number of frequencies, over summation f, total number of frequency, minus 1. So we substitute all the values into the formula. Summation fx squared, which is already calculated there, is 629,687 minus summation fx, which is 3801 bracket square over the total number of frequencies, which is 23, over total number of frequency minus 1, which is 23 minus 1. So the variance will get 69.57. Okay, now let us move on to the standard deviation. Standard deviation is basically the square root of variance. So square root variance is square root 69.57, we get 8.34. Okay, now let us move on to the interquartile range. In order to obtain the interquartile range, we must first find the first quartile and the third quartile. So to obtain the first quartile, you need to substitute all the values into this formula. So first we need to find LK. LK is basically the lower boundary of where the Q1 is located. Q1 is calculated by N over 4, which is total number of frequency divided 4, which is 5.75. 5.75 lies in the 155 to 159 class interval. So the lower boundary for that class interval is 154.5 plus N over 4, which is total number of frequency divided 4, minus the cumulative frequency before the Q1 value, Q1 which is 3. So minus 3 over the frequency of the Q1, which is 3, bracket C, which is obtained by subtracting the upper boundary and the lower boundary, which is 5. So we substitute all the values, we get 159.08. Next, we will calculate the Q3. Q3 is obtained by the formula 3n over 4. 3n over 4, 3n is total number of frequency, 23 over 4 is 17.5. 17.25 is located in this class interval, which is 170 to 174. So the low boundary for that class interval is 169.5 plus 304, which is 304 times number of frequency, minus the cumulative frequency before the class interval, which is 60. So minus 60 over the frequency of that class interval, which is 4 bracket 5, which is the class width. So you will get 171.06. So now we have obtained Q1 and Q3. To find the interpreted range, we must take Q3 minus Q1, which is 171.06 minus 159.08. You will get 111.98 cm.
Moving on, we have transferred the data into a STEM and beam format. Okay. First and foremost, the data we have to transfer it into right in order of from the least greatest to greatest. Okay. Then we have to find the greatest and least great value. So this is the greatest value, and this is the least great value. Okay. Then we have to choose the step. The step we have chosen is 15, 16, 17, and 18. Then we have to write them in vertical order. So right stem and write those numbers in a vertical order. Okay. Then we will show each piece of data by writing it once. Digit next is times it. For example, 151, 50, and one value 1 is right next to the stem 50. Then finally, we must write a key that explains how to read the stem and beam. For example, the key 15/1 represents 151 here, and finally we have to title the beam and the leaf plot, which is 9.
Moving on from the stem and leaf plot, now we are going to draw the box and whiskers plot. So to start with this process, first we should find the value of Q1, Q2, Q3, which we already did in the previous part. So we don't need to do again. We have already written the values here. With the values of Q1, Q2, Q3, we calculate the upper fence and the lower fence. First, we calculate the upper fence with the formula, which is Q3 plus 1.5 bracket Q3 minus Q1. Q3 substitute value is 171.06 plus 1.5 open bracket Q3 minus Q1 171.06 minus 159.08 equals we get 189.02. Now moving on to lower fence, formula is Q1 minus 1.5 minus Q3 minus Q1. Q1 which is 159.08 minus 1.5 open bracket 171.06 minus 159.08. You will get 141.11. Using these values here, you will now plot all the values in this axis. This axis is drawn on a particular scale. So to start with, we should start with the lower fence. Lower fence is 141.11. This basically here, we draw a dotted line, label it as lower fence, and then moving on to the upper fence, which is 189.03, which is not exactly here, but 189.03 is draw the dotted line, and then moving on to the this diagram. So first we will start with the minimum value of our data. Our minimum value is 151. So minimum value 150, 151 basically slightly here. Then moving on to the maximum value of our data, which is 183. 183 is slightly here. And then moving on to the Q1, Q3, Q3 plotting, which is Q1 which is 159.08, slightly here, Q1. Q2 165.75, 165.75. Q3 171.06, 170, 171.06. So that by then we need to connect all this, forming this diagram. Okay. Now using the values of Q2, Q1, we should also calculate this. Q2 minus Q1 is 6.67. Q3 minus Q2 is 5.31, which would be used in later part. Moving on to the graph, since our Q2 minus Q1 is greater than Q3 minus Q1, our graph is slightly steeper on this part and
Less deep.
less steep on this part. So by referring to the graph and to With the reference of calculation, we can conclude that our data is negative